All right, so welcome everyone. My name is Arthi Garg. I'm super excited to have you all here. I'm going to share my screen real quickly, and I'll ask someone to let me know when you can see my screen.
Looks good, Arki.
All right, great. Well, thanks so much. My name is Arthi Garg. I'm the founder and chair of Engineers and Scientists Acting Locally, and I'd like to welcome everyone to our event. Super exciting panel discussion that we'll talk about more in a second. Talking about addressing plastic waste through local engagement. But before we get started, before I hand it over to Rebecca to kick off the event, I just wanted to spend a couple minutes talking about Engineers and Scientists Acting Locally, who we are as an organization. And, we would love to engage more with you over the coming months and years. So as an organization, we're an all volunteer national organization with a pretty straightforward mission. We want to get more people with backgrounds in STEM engaged with their local governments and their local communities. And part of the way that we accomplish that is through events like this, where we want to help you understand the science and engineering dimensions of issues and policy decisions that are being made at the local level. Beyond panel discussions like this, we have a lot of other information on our website. We have a blog where we like to talk about organizations and individuals who are making big differences in their community. And we also have a whole host of tools and resources that we hope you will come and especially find useful after a discussion like today's, where you can learn about different avenues for engaging with your local government, whether or not you have a background in STEM, but places and ways we encourage folks to get involved. Jonathan is an example of somebody who is not only a scientist working on this issue, but also working serving in a local community advisory board, and he'll tell you a little bit more about that. That's actually how I personally got started in local government as well. Today's discussion is planned by our amazing events team. I'd like to recognize on the team Shan Lee. She is not able to participate in today's event, but she's done amazing work putting together this great panel of speakers. And so I really hope you enjoyed today's discussion. And I also just want to point out, I'd like to encourage you to visit our website, because next month on the 20th, we have another event coming up, which is Acting Locally to Advance Equity, and discuss different ways people with STEM backgrounds are working to advance racial equity in their communities. And so just to wrap up, super excited to have you all here, super excited for today's discussion. We would love to stay in touch after today by, having you get in touch, send us an email, join our listserv. You can, if you're interested in writing a blog post with us, that would be, or being featured, having you or your organization featured on our blog, let us know. And please sign up for our listserv so you can hear about more events like this in the future. With that, I am thrilled. I'm going to stop sharing my screen, and I'm absolutely thrilled to be able to hand this over to Dr. Rebecca Mant, who is our events director. She recently, and by recently I mean last week, defended her PhD in biological sciences at the Harvard Chan School of Public Health. She is very excited, after completing her PhD research, to begin her career in the federal government as a presidential management fellow. So with Rebecca, I'm going to hand it off to you. Please take it away.
Awesome. Thanks so much, Arti. And thanks to all of our panelists and to everyone joining on the call. We were very excited that this is a topic that generated a lot of enthusiasm and the most number of registrants we've had so far. So I'm going to go through and introduce each of our 3 panelists on the call, and then the structure for the event is they will each talk for about 10 minutes, a little more in depth about the type of work and the research they'll be engaging in, 10 to 15 minutes, and then we'll slide into a Q&A from the audience. So if during the talks or during that session you have questions you want to ask, feel free to pop those into the chat or into the Q&A, and we're hopeful to have like a lively discussion amongst everyone. So with that, I'll introduce our lineup for today. as Artie said, a really exciting panel with really really interesting folks. So we have Dr. Sarah Jean Royer, who's an oceanographer and specialist on plastic degradation in the environment. She's currently at the Center for Marine Debris Research at the Hawaii Pacific University at Scripps Institute of Oceanography at University of California, San Diego. And she's working on degradation of plastic in the environment, including synthetic microfibers, and trying to understand the different sources and sinks that connect plastic to the ocean. So her goal is to pursue this research and better understand the degradation and fragmentation of plastic and its fate in the ocean, and looking at plastic accumulation within the local environment in Hawaii. And her long-term objective is for policymakers to really use this data from scientists and volunteers to design better laws and policies. And then up next, you'll hear from Dr. Jonathan Krones, who's an industrial ecologist and sustainable solid waste systems expert. So his research involves developing new methods for quantifying different waste streams, evaluating the environmental effects of various circular economy and zero waste policies and practices, and exploring how product repair can decrease e-waste and increase resilience in our communities. So Jonathan received his PhD from an engineering systems program at MIT, and he was a postdoctoral scholar at the Yale School of Forestry and Environmental Studies. Currently, he's is a visiting professor at Boston College. And before his PhD, he also worked in energy and sustainability and climate policy and various functions at local, state, and federal levels. So you'll hear a little bit about that as well. And then finally, we have Miriam Gordon, who is the policy director for Upstream. Miriam is an alchemist of policies that reduce single-use products and packaging, and a leading advocate for plastic reduction policies. With over 30 years of experience working for NGOs and local, state, and federal government, Miriam is an expert on waste, water quality, and toxic chemicals policy. She's led campaigns to protect communities whose health is threatened by waste incineration, fracking, and hazardous chemicals. And she's created award-winning pollution prevention programs for a variety of business sectors. And Miriam holds a JD degree from the Vermont School of Law and was an undergraduate at Vassar College. So with that, I will go ahead and kick it off with our first speaker, Dr. Royer.
Thank you very much, Rebecca. So I will share my screen, and please let me know if it works fine. Wonderful. So I will be spending 15 minutes maybe, talking about my past work on the production of greenhouse gases from plastic in the environment. And I will go straight with the amount of plastic that is being discarded in the environment today. And if we don't do anything about this, these are the projections for the future up to 2050. This was an estimate by Roland Geyer and his team in 2017. And as a result of this, this is the type of debris that we find here in Hawaii. So I'm currently based in Hawaii, and this is James Campbell National Wildlife Refuge. It's a refuge where you need a permit to go, and you have very few people visiting this place. So most of the trash that we see is coming from outside of the Hawaiian Islands. It comes mostly from Asia because the geographical location of the Hawaiian Islands. But yeah, it's trash from everyone that's been traveling in the ocean for decades and end up on our beaches here. Half of this trash is actually coming from fishing industry, fishing gear, buoys, nets, lines, oyster spacers. So lots and lots of trash, sadly, than we see washing up on our beaches. If we look at the numbers, we have about 1 garbage truck of plastic that gets discarded into the ocean every minute. So this is a lot of trash. Then if I jump into the topic, so when I was at the Center for Marine Microbiology of Ocean and Education at Seymour, we did work where we were measuring actually methane from seawater, and this is work that I've been doing in my past. I'm a biogeochemist. I've been measuring gases in the ocean for over 15 years now. And we were trying to measure methane production, biological methane production from seawater. And we made the unexpected discovery. And this is Samuel Wilson and Sarah Ferrand. And plastic is emitting all these bad gases that are greenhouse gases, and they were actually looking at the production of methane from biological activities, but in their protocol they were using plastic bottles, and they realized that about 90% of the methane that was being produced was not coming from the biological activities, but from the bottle in which they were incubating seawater. Of course, after that, we switched to quartz vials, so there's no interaction between the bottle and the emissions of the methane by itself. But I found it very interesting, and I decided to continue working on the topic. And what happened is the questions that we were asking was like, which plastic type produces the most hydrocarbon? And when I refer to hydrocarbons, I refer to methane, CH4, ethylene, C2H4, so all these molecules that have a C and an H. So that's what we started with, and we did several experiments where we would put all these 7 different types of polymers that are the most used around the world. So they are polycarbonate, acrylic, polypropylene, PET, the plastic bottles, polystyrene, HDPE, and LDPE. And then we would incubate them in quartz vials, and after 7 days, we would look at the production of greenhouse gases using a GC, a gas chromatographer. We also had dark treatment to see if the light has an effect different from dark. So, and what we realize here is that all of these 7 most commonly used types of plastic around the world are producing greenhouse gases. So methane and ethylene, all of them in the light treatment, they produce these gases. And the one that is producing the most is actually the low density polyethylene. And sadly, low density polyethylene is the number 4 in your recycle bin. This is also the type of plastic that is being used for plastic bags, containers, etc. And it's also the type of polymers that is the most produced around the world. Is the one that has a density lower than seawater, which means that when it gets discarded into the ocean, it will float. And also it's expected to increase in the next decades with a global demand for polyethylene resins rising 4% per year. So LDPE causes a lot of problems. It's also very cheap. It has a weak chemical structure. It degrades faster in the environment, and it's the most discarded types of polymer in the environment. And also the polymer that will be produced the most greenhouse gases. So then some of the questions that we ask about this type of polymer was, does the concentration of the hydrocarbon gases keep on increasing with time? And for addressing this question, we look at the production of hydrocarbons, so greenhouse gases, for a period of 200 days. So this is the x-axis, which are the days, and this is the accumulation of gas over time. So over here, what is interesting to see is that not only it's producing gases with time, it's increasing. So the concentrations keep on increasing with time with LDPE, low density polyethylene. So that was with the virgin LDPE. So what we decided to do, we decided to go at sea and basically to look at polymers that we find in the ocean. So we threw aboard a manta trawl to scoop the ocean surface, and we collected microplastic at the surface of the ocean. Then we use Raman spectroscopy to be able to look at the type of polymer, and we found the blue line here is actually the spectra for the virgin LDPE that I showed earlier, and the red one is the spectra for the aged LDPE. So basically the polymer that we found in the ocean in the North Pacific garbage patch. So we knew that we are looking at the same polymer type, and then we incubated the same polymer over a period of 160 days. And we also realized that for the 4 different types of greenhouse gases that we are measuring, we see not only that it's producing greenhouse gases with time, but it keeps on increasing with time. So the polymer continue to emit gases to the environment for an undetermined period of time. So we had to stop at some point. We did it for 1 year, but we knew that it will continue with time. And what we think here is that due to photodegradation of the plastic, we have this creation of micro cracks and fracture of the polymer, and this is what actually causes the increase over time, is just the increase in surface area of the polymer, because even if it's not breaking down or breaking up into several pieces, in one single piece, we will have a larger surface area if you start having cracks and microfractures. And this is what's causing more concentrations over time. It's just because there's more of it that can react with the sunlight. And then after that, to confirm this, we took these microplastic pieces and we looked at them under a biological electron microscope, and we looked from a close point of view all of these cracks and microfractures. So this is just to show you that yes, we see plastic pollution in the environment. It's very visual, and but when you look at microplastic and you look at it from a closer point of view, you can see all these imperfections. And with time, the more sun the plastic will absorb, the more surface area it will create by having these micro cracks and fractures. So then another question that we asked were, does the concentration of the hydrocarbon gases keep the same production rate when fragmentation occurs? So here, I mean, when you think in terms of plastic in the environment, it degrades with times and it becomes smaller and smaller, and it fragments into smaller pieces. As you can see here, these are microplastic fragments that we find on the beach in Hawaii. So what will be the effect of this fragmentation over time? So what we did, we took powder form of LDPE and we took pellets, so pre-production plastic pellets, and for the same polymer and the same weight, so let's say 5 grams of each, we got about 488 times more methane that are being produced using the powder compared to the pellets, which means as plastic fragments in the ocean into smaller and smaller pieces, for the same amount of plastic in weight, we'll get more and more gases that are being produced, which is super problematic because we know that all of this plastic that is currently discarded into the environment will fragment with time. So I guess the last question that I wanted to address here is, of course, I'm an oceanographer. I've been studying the ocean for decades now, and I'm really interested into looking at plastic submerged in the ocean. So we started all of our experiment with submerged plastic in the ocean, but then we wanted to have a similar and comparable study where we look at plastic actually exposed to UV light and not submerged in water, such as the plastic that we see here at Camilo Beach on Big Island. So we conducted a similar experiment, same plastic with the same density, same weight, and we looked at it exposed to UV light directly and air, and then submerged in water. And what we discovered to mimic these different types of items that we have is that this was scary because we realized that we have about 3 times more methane when plastic is exposed to air rather than submerged in water, and 76 times more ethylene, C2H4, which is also a greenhouse gas that is being produced when exposed to air rather than submerged in water. So this means then we no longer think in terms of only plastic pollution in the ocean, but we have to think about all of these different items that we use on a regular basis that are exposed to UV light and emitting all of these greenhouse gases. So it's not only about plastic waste for this specific topic, but it's also plastic in general exposed to UV. So that has a huge impact on the emissions of greenhouse gases. So here I put a slide together where I kind of put all of my experiment together. So just to show you that solar radiation and UV light is not the only factor that will affect the production of greenhouse gases, but we have to think that all these different shapes, so this is powder, flakes, pellets, the surface area is a big one. So as plastic degrades and fragments, it keeps on producing greenhouse gases. So we have to do something about this plastic out there in the environment. Then in air versus water, so we get even more greenhouse gases produced when plastic is exposed to air. Then plastic will keep on producing emitted greenhouse gases when it's nighttime. So we know UV light is very important, and it really increased the amount of greenhouse gases. But when it's nighttime or in the dark, we keep having this emission of greenhouse gases as well. And the temperature, so as the temperature increases, there's more and more gases that are being produced. Once the plastic is removed from the environment, then the water that was surrounding the environment is also emitting greenhouse gases because of all of these nano and picoparticles that we don't see that's been released. So this is something to think about when we use plastic. Is it has an effect at the precise moment, but this effect will be carried out with time because of the trace that plastic leaves behind. So I just put here like an overall slide that shows you that as we produce, use, and dispose on land and in the ocean plastic, we have a trend where we see an increase in the emissions of greenhouse gases as plastic degrades in the environment and fragments and becomes smaller and smaller in pieces. So we have to think twice about our consumption and about the way that we will be, if we consume plastic, discard this plastic. So what are the next steps for this study? Of course, we want to know what is like the significance of the emissions of greenhouse gases, and we already see that there's a link with climate change, and this is making a significant contribution, but we have very little data about the amount of plastic globally that is exposed to UV light and that is being out there. So we have a few projects with the NASA and the European Space Agency where we are trying to find a way of developing satellite to be able to estimate the total amount of plastic out there. So the total amount of plastic in terrestrial environment, but also floating in the ocean. And then to finish in terms of more general next steps, so I like to think in terms of we have all of this plastic that's been produced in the past and that is currently being discarded also in the environment, and we need to do something about this. And we have all this plastic that is projected to be made up to 2050, and that will keep on increasing if we don't change anything. So the plastic from the past and also the plastic that is currently being disposed in the environment and discarded, we need to do something. So for this plastic, we need to be active about it. We need to be picking up the plastic. We need to have all these different organizations at the same time helping in collecting the plastic and removing it from the environment, so it doesn't keep on degrading and fragmenting into smaller and smaller pieces, because the more it fragments in the environment, the harder it is to collect. But also the more it fragments in the environment, the more effect it has, for example, on the food web. So the smaller the pieces of plastic are, the easily they will be available for smaller and smaller organisms in the food web. And we all know that, I mean, we eat fish, we eat organisms from the ocean, and hence if they eat plastic, even though we don't eat always their stomach, the compounds that are being released into the flesh, for example, will be ingested by us and might have some pretty gnarly effect on human health. So this is really something that we need to do. We need to remove this plastic that is out there. And we know that there's a lot, and we need these organizations such as the Ocean Cleanup to clean up the ocean, and beach cleanup organization to clean up the shores of the different beaches all over the world. And I wanted to put this picture of me back in 2009, where I started also doing this project that was called Run and Care. So I wanted to do something about all of this plastic that I would see in the morning when I go to work. I used to work in Barcelona. I did my PhD there, and the beach over there was filled with plastic trash. And sadly, it's all local pollution. So it would be like beachgoers, tourists that will go out there for a night and evening and leave their trash behind. So I started this group called Run and Care, where I will go with friends running and then picking up trash along the coastline while running. So we would merge two activities, and I did this for a very long time. And now I like to see that the movement is now large, and it's called plugging, which is picking up the trash while running. So yeah, I just want to encourage people, when you see trash out there, instead of just looking at it, just do something about it and pick it up. It will help. But at the same time, it's not a solution for the future, because we don't want to tell people that you can keep on basically consuming plastic, and whatever way it gets discarded, there will always be someone out there to help with picking it up. That's not the message that we want to do. And I think for the future, we have to think in terms of a solution that is more viable. So the single-use plastic that we use on an everyday basis, it's not really a solution. It's not something that has to be done, because it's more for convenience. People would use like single-use plastic cups and straws just because it's more convenient. But the truth is that we need to basically not have single-use plastic in our life anymore. And the solution is quite simple. It's just to change the way that you deal with your everyday life. Instead of leaving in the morning and having to take your wallet and your key, then you take your reusable bags, you put a bottle of water in there. You can put also utensils and straws that are reusable and that you can clean. So it's just a way in life that you change your habits. And for this, we need the policymakers to help us, because it's not that easy to change habits. It's easier for kids to adopt this different lifestyle, but the older people get, I feel like the harder it is for them to change their own habits. So we need to have learned policymakers helping us, like refusing and then just banning completely single-use plastic to help having having better policies for this. Then after that, if you see these items that are out there, so this is the Maldives, and sadly, there's a lot of plastic trash there, and this is the result of using plastic bottles on an everyday basis, and then not having any proper plastic waste management. So Parley, they actually reuse plastic, and they actually use the PET plastic bottles to make running shoes. So these can be like sexy solutions for the future to use with the plastic that's been discarded in the past, but these are not necessarily solutions for the future. We just need to have better laws and also better material to replace plastic. So I think I passed my time, but thank you very much for your attention, and please feel free to ask any questions you have.
Wonderful. That was a super interesting presentation. Really cool to see some photos of also you doing this work in action. And so I know that there's been a lot of questions coming in. I've saved any that came in through the chat, and so we'll get to those kind of after everyone has presented. Although I do want to note that one comment that came in was that this talk needs to be presented to the EU, the UN, and everywhere. So I think you're very, very appreciated talk. And I think that really is going to jive well, especially with some of your endpoints with some of what we'll hear from Jonathan and Miriam. So with that, I guess we'll move on to our next speaker, which is Dr. Jonathan Krones.
All right, is my screen showing?
Yeah,
great. So hello, everyone. I'm so happy to be here to talk with you a bit about my work on solid waste and sustainability and my involvement with public policy during my career. I'm an engineer and an industrial ecologist. Industrial ecology is the study of the stocks and flows of materials and other resources through human industrial systems and between those systems and the environment. It's a systems science. So when industrial ecologists examine a particular environmental problem, we take a broad life cycle view. This life cycle perspective sometimes helps to identify root causes of problems, but more often serves to illustrate the complexity of environmental issues. One of the most important models we have in industrial ecology is that of societal metabolism or socioeconomic metabolism. Here we think of an organization or a city or country or even the whole world as embedded in an environment, just as organisms are part of their environments. Our human system draws or ingests natural resources from that environment, consumes them, converting some into stocks like buildings, built infrastructure, manufactured goods, and converting others to generate services and value. Degraded resources are then returned, or to torture the metaphor, excreted back into the environment. There's a lot we can draw from this model. One thing is to say that the size of those arrows connecting the human system with the environment is going to be roughly proportional to the magnitude of environmental pressure or harm. The input arrow is correlated with impacts from mining, agriculture, forestry, fishing, with all the ecological changes that those activities entail. The output arrows represent air and water pollution, CO2 emissions, solid waste. As population grows, as the demand for material stocks and services grow, the input and output arrows will grow too, and all else being equal, and increase pressure on the environment. This is obviously a tremendously oversimplified picture. It doesn't take into account technology change, for example, but there is a detail worth highlighting, which is that there are outputs coming from both production and consumption. Our environmental discourse too often focuses primarily on consumption outputs, both in terms of consumption wastes like municipal solid waste, MSW, and also how individual consumer decisions can affect climate change, greenhouse gas emissions. Taking a systems perspective, even one as simple as this, shows that production might be a more important leverage point in environmental fluxes, both directly, as producers are responsible for the inputs, as well as having their own considerable outputs, and indirectly, in that producers make the decisions that impact what consumption, and by extension consumption wastes and impacts, can have. This insight is of central importance to the debate around single-use plastic and plastic waste, and I'm sure we'll return to it later this session. The diagram evokes ecological economist Herman Daly's idea of a full world, where the large size of the physical economy vis-a-vis the environment means that continued economic growth is irreversibly depleting vital natural capital. The same caution comes from Johan Rockström and the Stockholm Resilience Center, which has identified a set of planetary boundaries for human activity, having mostly to do with the magnitude and character of these input and output metabolic flows, although there are also significant land use and ecosystem integrity components to both Daly's and Rockström's models that aren't well captured in my diagram. But both Daly and Rockström and much of the sustainability community make the argument that in order to reduce the magnitude of the environmental fluxes in and out of the economy, we must reduce material throughput, that central arrow. By shrinking that central arrow, the other arrows will shrink accordingly. Industrial ecologists and others have argued for a long time that there's a complementary approach, and it comes from looking at waste as a potential resource. By redirecting the output flows back into the economic system, we may be able to substitute some inputs with outputs, maintaining a little bit more of a material intensive society while decoupling from environmental harm. Recently, this has become known as a, quote, circular economy, although it's been developed both conceptually and in practice under other names for many decades. I'm not naive about the real limitations of this proposal. Too often, recycling and circular economy policy proposals are masking blank checks for industry to continue business as usual practices, while focusing civil society and government action on mere busyness, as Samantha McBride argues so convincingly in her book, Recycling Reconsidered. However, there do remain real questions about the extent to which circularity, as the contemporary term of art, is actually feasible. So this is the central question that's motivated my research. It's taken me in a number of interesting directions. A lot of my work has to do with improving quantification of solid waste systems. There's going to be stuff on the slide in a moment. Any solid waste professionals in the audience will be sympathetic. Garbage data is too often frustratingly just that, garbage. The EPA maintains robust assessments of many consumption wastes at the national scale, but beyond that, our accounts of solid waste are inconsistent at best. So consider non-hazardous industrial waste, which includes all the materials process residuals like ash, slag, paper-making sludge, pollution control wastes, and similar things. These are important wastes because they actually have been demonstrated to be valuable substitutes for raw materials in many construction applications. The official estimate of this waste stream, as you can see here, is 7.6 billion tons. That's 6.9 billion metric tons. That's billion with a B. More than 25 times greater than the 265 million metric tons of MSW generated in 2018, according to the EPA. I dug into the origins of this very large number and found that not only is it more than 30 years old, it does not represent what it purports to represent. I can talk more about that in the Q&A if you're interested. So I developed a new number, a new model of these hazardous industrial wastes, and found that the actual number is actually closer to 250 million metric tons as of 2015, which is the same order of magnitude as MSW. And a significant fraction of this is phosphogypsum, a residual from fertilizer manufacturing that's recently been in the news due to the surface impoundment leaks in Florida. So an interesting corollary to this work came from my forensics into the origins of that 7.6 billion tons number. With colleagues, I've been developing the idea of a charismatic environmental number, a measurement of some environmental phenomenon that gets decoupled from its original context and is used instead for its affective rather than its scientific power. We find a lot of these in the solid waste world, in part because the accounts, as I mentioned, are often incomplete or updated inconsistently. Something to watch out for, if you see some figures repeated by environmental groups or the media, I'd ask you to approach them with a bit of healthy skepticism, as in, where did that number come from? Does it mean what the author thinks it means? Oftentimes we find environmental numbers repeated from one article to the next without interrogation of their origins. So I'm happy to go into more detail in this later too. My research also investigates sustainable waste management proposals. When companies or cities offer new approaches to waste management, it's prudent to critically examine them from an industrial ecology systems perspective. Do they do what they claim? Are there unintended consequences elsewhere in a product life cycle or in a societal metabolism? Are they scalable? I'm not going to go into great depth here, but instead give some examples of my work in this area. So in a project funded by Waste Management, the garbage company, I conducted a life cycle assessment on the environmental effects of the transition from dual stream recycling, 2 bins, to single stream recycling, finding that at least in the year following a switch, at the time we did the study, the increased volume of materials recovered could offset any sort of increase in energy consumption in the recycling facility and the decreased quality of the outputs. I've got to say, this study has not aged well. The quantity quality trade-off that is highlighted in the study and is endemic to single stream nationwide has been revealed to be a really bad bet. And this was revealed once sort of the China's national sword policy went into place. And I know that activists and community members had been yelling about this for a really long time. And so finally, it was known definitively. So I also looked at a collaboration between a regional waste company and a specialty manufacturer in New England as a promising model of industrial symbiosis, a form of eco-industrial development where outputs from one industrial process can be used directly as inputs in another. Here, efforts by the manufacturer to become a zero waste factory created the conditions for the waste company to find beneficial uses for wastes from many other manufacturers in the region. More recently, I looked at the environmental and social effects of an app-based food rescue and redistribution service and found that it's actually really effective at avoiding food waste, but it's much less clear if it avoids consumption and therefore production of new food. I have other work along these lines in progress, including a study of the future of the waste to energy incinerators in Massachusetts, given the dual pressures of decarbonization and waste reduction, and plastics are a key element in that dynamic. Moving a bit away from engineering, I've also looked at questions of waste governance, including a project that explored the conditions for organics recycling in mid-sized US cities, and also something that I took a really critical, from like a critical social studies look, a sociology look at these very trends. So in addition to my academic research, I've been involved in environmental public policy throughout my career. In fact, I sought out opportunities to work in policy. So if there's any sort of students on the call, I sought out opportunities to work in policy during graduate school as part of my training. During my master's, I spent a summer working for a utility commissioner in New York City, which ended up being the best energy education that I could have hoped for. That year saw the Marcellus Shale fracking boom and the New York State government banning fracking in New York. Early development and therefore a natural experiment because we could just drive over the border to Pennsylvania to observe differences. Early development of offshore wind proposals in New York and New Jersey, the threat of a death spiral in the Manhattan district heating system. This is a cool map from 1932 and the system looks pretty similar today. But small scale combined heat and power plants were becoming much more affordable. So actually a quick anecdote here. Before starting that job, I asked the commissioner for some reading assignments. I'm an engineer, but he's a regulator. So I was expecting a law textbook, economics of deregulated energy markets. But instead, he asked me to read The Power Broker by Robert Caro and Bonfire of the Vanities by Tom Wolfe. And the lesson I took from that is that the best, most genius technical or environmental plans are subject to the whims of power and money. And this could have been a cynical lesson, but instead I took it as a mandate to seek out opportunities to get involved with policy and use my expertise and a good bit of moral indignation to try to move the needle on waste issues. I had an opportunity to do this less than a year later when I joined the White House Council on Environmental Quality as an intern in the Office of the Federal Environmental Executive. We were charged with implementing President Obama's Federal Sustainability Executive Order, 13514 for any EO wonks out there. Which among other things required all federal agencies and departments to increase waste diversion and to conduct a carbon footprint and develop a plan for emissions reductions. I saw the value, but again, the limitations of being the person in the room oftentimes, not always, but often with the most scientific and engineering expertise. If I couldn't make the argument that a particular action was well aligned with an agency mission, it was much less likely to pique the interest of whatever deputy undersecretary dragooned into being agency senior sustainability officer. When I returned to Boston for my PhD, I wanted to stay involved. I was hired as a consulting data analyst through the Barr Foundation to develop a data dashboard and scorecard for Massachusetts in its efforts to meet its statutory obligations under the Global Warming Solutions Act. The state government was moving a bit slowly on embracing data transparency in that area. And I like to think we may have forced their hand a little bit. Today, many of the metrics that we put into that scorecard are used internally and externally by the state government to track and communicate progress. In 2017, the city of Boston announced that it would begin a zero waste planning process and was putting together an advisory committee made up of representatives from the neighborhoods, key industry sectors, and civil society groups. I was in a position to volunteer to represent my neighborhood on the committee. I don't think the organizers really knew that they had someone with my expertise joining the citizens group, but it ended up being really important as I was able to critically engage with the data and the proposals from the consultants that many of my fellow committee members could not. And now having been a consultant, there's an element of sort of going through the motions in a planning process. And I think I may have taken some of the consultants aback because I was able to ask where that number came from, for example. If you're interested in learning about the plan, you can read it on the city's website. I really don't know the status of the plan today, especially because there's a new mayor, but it's a pretty good plan, I've got to say. A good focus on synergies among planning actions, economic development, environmental justice. Something I learned is that policy planning doesn't require the level of rigorous analysis that I'm familiar with as an engineering professor. There weren't many waste companies in the room either. And there was sort of the assumption that the desired outcomes were both technically and economically feasible, even though the reduction targets were as much a political statement as an actionable goal. Participation on this committee also led me to be involved with the Carbon Free Boston report that actually did the rigorous analysis. A team at BU did it on the greenhouse gas implications of the zero waste proposals, including single-use plastics bans, and found maybe concerningly some very persistent emissions from the waste and wastewater sectors that aren't affected by waste reduction policies. That's a pattern I also found when I developed the non-energy emissions sector report for the Massachusetts 2050 Decarbonization Roadmap Study last year. So the last thing, I'm a bit over time, I'm going to talk even faster if you can believe it. The last thing I want to talk about is the work I do in the community to materially reduce waste, and that's community repair. It should come as no surprise that we live in a throwaway society. Even our electronics and household appliances are becoming increasingly disposable. Virtues of thrift and repair are disappearing with our older generations, and it's resulting in rapidly increasing volumes, not just plastic waste, but also of electronic and durable good waste. After this New York Times piece came out in 2017 about repair cafes, I started one in my neighborhood, actually at the neighborhood branch of the Boston Public Library under a different brand name, Fix-It Clinic. This event proved to be extremely popular and durable, and I ultimately helped start community repair events in neighborhoods throughout Boston and the surrounding cities and towns. Our success with engaging a multi-generational group of people around issues of repair led the State Department of Environmental Protection to offer incentives to municipalities to hold these events. And just before COVID, the city of Boston was about to launch a project aimed at embedding repair into many of the branch libraries, particularly in underserved neighborhoods. So, I take off my data analyst hat when I do repair events. So I don't have a great idea of the tonnage of e-waste avoided as a result of these events. Others are trying to collect that data, but I think it misses one of the key goals, which is to build a culture of repair and to get people to think differently about their consumption and disposal habits. My work as a scientist and an engineer informs the urgency of community educational events like these, and there have been fruitful feedbacks, such as research that I'm doing on the potential for community repair to contribute to waste reduction goals and to develop ideas around design for repairability. So thank you for listening to my stories. I'm looking forward to talking about how lessons learned from these experiences can inform current policy debates around plastic waste.
That was really excellent. I think it's totally okay to take an extra few minutes because I think this is going to stimulate a lot of discussion and really jives so well with as Artie in the beginning mentioned the overall mission of ESAL, and a great example of what it can look like when a scientist has these different hats of community engagement and local policy work. So very cool. Thank you. And then finally, we'll hear about a little bit of a different perspective from Miriam Gordon of Upstream.
Great. Can you see my slides? Yes. Wonderful. So I'm going to be, I'm a lawyer by training and a policy director, and I view my job as my client, first of all, is the environment and our communities, our health, and the people and the planet. And what I try to do in my work is to understand the technical background and translate it into policy. So I work with a lot of technical experts and scientists, and I can give you citations to the talking points that I will present if you want them. But normally I don't speak to such a technical crowd, so you're going to hear more of a presentation on how we talk about transformation to a whole wide array of stakeholders, generally not very technical ones. So first, I want to talk about Upstream and who we are. We're a national NGO. We were founded in 2003 by two of the founders of the US Zero Waste movement. And their idea, we were called the Product Policy Institute. Their idea was that we could solve our enormous waste problems by making producers responsible for the products they put into commerce that become waste, rather than leaving it to taxpayers and local government to manage it. Because if the producers had the financial responsibility, our founders believed they would generate less waste. So they're always interested in reducing waste at the source. We set up many product stewardship policy organizations across the country that addressed a wide array of different product categories, from batteries to paint, light bulbs to mattresses, carpets. Unfortunately, the idea that producers would generate less waste when they became responsible for it isn't what resulted. Primarily, the focus was of these laws was on collection and recycling more. And when our organization started grappling with single-use plastics and packaging problems, we realized that we needed to start to move the dial from the downstream waste management approach to the upstream approach, the prevention approach, which is finding ways to reduce single-use disposable products at the source. And we were so invested in that idea that we rebranded ourselves as Upstream. Now, single-use plastics and packaging are the products of a throwaway culture. And endemic to this culture is the hubris that it's okay to use the planet's resources to make products that we only use for a matter of minutes. It's okay as long as we manage the waste properly, even though managing that waste properly requires a lot of energy and resources to collect, transport, and process the product. It creates a lot of pollution. And so much of this waste management system is riddled with falsehoods. And most of the effort on the waste management side has been focused on how to recycle and compost more of the waste associated with plastics and packaging. So let's consider these waste management approaches very briefly before I move on. So one thing is that recyclable products aren't necessarily recycled. U.S. and partly the China ban on imports of our dirty, contaminated paper and plastic revealed this problem that actually, when our U.S. communities have to deal with these products, suddenly they were grappling with huge shortfalls between the costs of collection and sorting and the resale value of the products. Many communities went from getting paid in the last few years for products for recycled materials put into the marketplace to now having to pay for products to be recycled. And in recent years, US plastics recycling has dropped. It was expected to drop from 8.4% in 2017 to 6.6% in 2020. And in the area that we deal with, which is mostly single-use foodware, because that's mostly what has been ending up in our beaches and raising awareness about the problem of plastics in the marine environment, the macroplastics are mostly foodware. Foodware is almost never recyclable once it's contaminated, neither the paper nor the plastic. So recyclable isn't always translating to recycling. And then there's the compostable scenario, which a lot of environmentalists have embraced through the last few decades. The problem is that compostable packaging isn't what commercial composters want. They want the high nutrient value food waste and yard and landscape cuttings. The processed packaging adds no nutrient value to compost. It dilutes the compost quality, lowers its value, and it contributes to a fair amount of greenwashing, particularly when it comes to compostable packaging, which has to be certified by a third-party certification company to be accepted in a commercial compost facility. The problem is that the certification in the lab requires a longer degradation time than is actually required in the field. So we have a lot of compostable plastics that if they get into a compost system are a contaminant. So usually many of the commercial composters are screening this stuff out either before or after, and these materials are sent to landfill and incinerators anyway, which means that there's higher greenhouse gas emissions associated with them. Then there's the problem of creating toxic compost with food packaging. I've asked for 2 studies to be shared that show that paper and fiberware products are coated with fluorinated substances, the PFAS chemicals, the forever chemicals in many cases, and that those chemicals leach into compost and create toxic compost. Even more interesting is that the bioplastics, the PLA, polylactic acid, and other green bioplastics have also many of the same chemical additives that are in traditional plastics, and these also can leach into the ground, into compost, and create contamination. These products contaminate our recycling when they get confused with recyclable products, and on balance, compostable foodware costs businesses a lot more. And we feel not necessarily justified given all the problems with these products. In fact, all of the commercial composters in Oregon put out a statement about 3 years ago saying that they don't want any compostable foodware or packaging for all of the reasons that I discussed. And we find that to be a trend, not necessarily 100%, but many commercial composters are saying the same thing. I want to push back a little bit on just the premise of the whole focus here on plastic as being the problematic product. I appreciate everything. I thought Sarah's presentation was amazing, and I too hate single-use plastic for all of those reasons and more. But I think we have to think about the problem being single use, everything single use, because the substitutes for plastic, we could do entire webinars and semester-long classes on the problems associated with single-use paper and growing products to make bioplastics, and the fiberware and the aluminum and the trees that and the wood. All of these other alternatives have many associated environmental harms. So we need to be careful about what we are choosing instead of single-use plastics. And in Upstream's case, we think that what we need to do is change the throwaway culture that's contributing to our climate emergency, depleting natural resources, polluting our communities, and damaging our health. So at Upstream, we're working to create a world where both people and the planet are treated as indisposable. And how we're doing this is we believe that the priority needs to be to find ways to get people what they want, the products that they want to consume, without the waste, without the unnecessary packaging, and change the packaging format to reusable and refillable. I work with a lot of policymakers who still want to know, okay, but what are we going to do about the single-use stuff that we still have? What's the best format for the single-use packaging? That is a really hard question to answer. But currently, the way we answer it in policy is that, yes, recycling and composting are better than landfill and incineration, maybe, usually, but it's important that when we ask for our products to be recyclable or compostable, they have to be recyclable or compostable in the local waste management program. Doesn't matter if it's technically recyclable or compostable in a lab setting. You actually have to have waste management systems that can handle these products. And so increasingly, the policies that we work on, we're seeing legislators say, yeah, it has to be. And so for a lot of the California communities where I work, they're just moving towards non-plastic compostables, fiberware, and we are specifying that they have to be free of chemicals like the fluorinated substances and the phthalates and the bisphenols that are, well, bisphenols aren't related to compostable, but free of these harmful chemical classes. But our primary focus is on reduce and reuse. I mean, you don't have to have a PhD to understand that preventing products from being generated in the first place is going to benefit the planet and its people. It just makes common sense. But we still have to understand this from a technical standpoint. So we've spent a fair amount of time diving into the LCAs, the life cycle analyses and assessments on single-use food packaging versus reusable food packaging. And what we've discovered is that reuse wins every time as long as the reusable product is used enough times to get to the to get beyond the break-even point with the disposable product that it's replacing. So on average, we can say that in general, reusable products have to be used between 2 and 100 times to beat the single-use products that they're replacing. And of course, many of you are technical experts, and you know that this all depends on the assumptions in the life cycle analysis. But having dived into and evaluated about 30 foodware LCAs related to this business sector, packaging and food service sector, we can say that this is a good general takeaway. We also know that reuse wins for the business bottom line. The Ellen MacArthur Foundation said that switching to just 20% more reusable formats for packaging is valued at about $10 billion worth of savings. And I started a program in 2012 called Rethink Disposable that works with food service operators one-on-one. And we can see that with just a few little tweaks for on-site dining, like changing from disposable utensils and napkins and glass and plastic cups, really simple changes can save a business between $3,000 and $22,000 a year. So it's being proved, reuse is proving itself to be even net after any additional dishwashing and purchasing of reusable products. We also know that we taxpayers are spending a lot of money so that our local government can sweep the streets and remove litter and maybe put in some stormwater capture devices. Communities are spending in the US, this is probably very conservative, over $11 billion a year to clean up litter. And we also know that reuse creates jobs. It was estimated by EcoCycle that reuse creates about 30 times more jobs than recycling and landfilling. So what we do is we focus on policies that make reuse a reality in our communities. And I want to just invite you on a tour of the indisposable communities that we are creating. So just imagine that you sit down, we're creating through our policy work. Imagine you sit down at a local fast food restaurant and they serve you with reusable cups, plates, and cutlery, as McDonald's is now doing in Europe. Or you go to get a coffee and it's available in a returnable, reusable cup. Or you go to the ballpark or a concert and everyone is using real cups. Or when you need to replace some cleaning products or personal care products, you're able to meet the little electric powered tricycle delivery system that will refill your reusable containers for your products. These kinds of systems are being escalated and innovated all across the globe and in the communities where we are working. And these are communities where single use is becoming ancient history. And much of it as a result of innovative business solutions and also the policies that propel those innovative business solutions. So we work at the community level, cities and counties across the country, to make sure that for on-site dining, businesses are only allowed to serve customers with reusables. And we had 4 cities that did that just before the pandemic. We have many more teed up right now about to do that, and one piece of state legislation in California that has proposed that. We got 9 cities to pass charges on takeout cups and 1 on takeout containers. That is making it so that bringing your own reusable or borrowing a cup or a container from one of those businesses makes more economic sense for the customer. And we're focusing on our Skip the Stuff campaign, where accessories to those takeout and delivery orders are only available if the customer specifically requests them. And we have many cities and now states that are adopting this policy. So beyond transitioning food service to reusable, in our networks, in our national reusable network, we are also talking about other ways to create indisposable communities and culture. I loved that Jonathan was talking about fix-it clinics, because the whole right to repair in policy is about making sure that we have products that are fixable and repairable. We also are having some success. California said no to single-use toiletry bottles in hotels, so we can have our personal care products in hotels delivered from bulk systems. Dry cleaning and groceries can be obtained through reusable systems. We're working on refillable beverage bottle policies for the states that have bottle deposit programs, and for states that don't have them. Water refill stations, there's all kinds of ways to create indisposable communities. And now we're doing this through policy at the local, state, and federal levels. So just in closing, how Upstream is growing the reuse movement. We are leading local reusable city coalitions in the San Francisco Bay Area, where we have staff capacity. Where we don't, we are seeding these reuse coalitions. We've created reuse coalitions in Los Angeles and New York. We have ones launching right now in Boston and Providence and other cities that are where we are targeting the development of these coalitions to advocate for these business solutions and these policies. And we feed all of these coalitions and our national networks, our national reuse network and our national government reuse forum with information and policy campaigns and the marketing of an indisposable community vision. So I encourage you to join the reuse movement, sign up for our weekly emails, follow us on social, tune into the Indisposable podcast, and subscribe to our YouTube channel to hear about the heroes of the reuse movement and be inspired. Thank you. Let me stop sharing.
Awesome. That was great. A lot of, I think, good suggestions from everyone about ways individuals can get involved, whether it be through picking up trash or these reuse clinics or more on the advocacy front. So this is very cool. We have about 20 minutes. So I'm going to start with a couple of broader questions that were sort of pre-planned from everyone. And then we're going to take audience questions. I realize we may run out of time, so just so folks are aware, the panelists generously agreed to share their emails with the participants. We'll be sending out at the end of this a write-up, the recording, as well as a list of all the links that we're sharing with you today in case you missed any of them that are going on in the chat. So I think with that, I'll jump into my first question, which stems again from this theme that we really embrace at ESAL, that people with backgrounds in STEM or folks who are engaging with scientists can really play an important role in bringing evidence-informed perspectives to solve these important community issues. So two related questions stemming from that. We've learned a lot about how we study from a couple different perspectives, the environmental and health impacts of plastic waste, but what are some of the open questions in this field of research, and how can we think about addressing them? So I think this is two-part, but I'll stop there since that's a big question in and of itself, and give maybe we'll anyone who wants to jump in can answer. Go for it, Jonathan. I'm seeing a look from you.
So I can't speak so much to sort of the study of the health impacts necessarily.
Yeah.
But there's still a lot we don't know about from an academic perspective, we don't know very much about the environmental impacts of a lot of the solutions that have been proposed, and really plastic waste in general. I mean, once you start doing lit reviews into the actual research that goes on in kind of ocean plastic, you realize it's, you know, small numbers of teams worldwide that are working on this. I think, you know, the big funding agencies are starting to move in a direction of being more interested in this sort of work. So, you know, I think one thing that I found to be really a great opportunity is to sort of find activist groups or you know, city efforts to focus on that are focusing on some of these questions, and partner with them to create research questions. I think I've had a lot of success getting private foundation funding for academic research where you have a sort of a practical partner. I think in Europe they call this transdisciplinary research, where you co-generate a research question with a practitioner. So I think that this is a great opportunity for that sort of research.
Yeah, definitely.
I'd be happy to talk for a second about research into health effects of plastics and where we need to go. I've been working on plastics for, I think, almost 20 years now, and we've learned so much about the quantity of plastics in the marine environment. Every year we have way more research on, you know, where it's showing up in the environment, not just the marine environment. And as we saw from Sarah's presentation on environmental impacts in the environment. But I think on the health side, how microplastics and nanoplastics are impacting our health is a big area for research. We have a project called the Unwrapped Project. I provided a link, and you'll see that we had a conference on this in June 2019, and where these researchers that came and presented at our conference were talking about the big unknown is what happens when these microplastics get into our bodies. We know that when they're small enough, they can cross all kinds of barriers, the blood-brain barrier, the placenta, they can accumulate in our organs, they can get into our brain, they can, you know, potentially impact the fetus, but what do they actually do once they're in the body? This is an area of emerging research. So if any of you are more on the, you know, human health side, that's very important question.
Yeah, yeah. Sarah, anything to add?
Yeah, no, I think they both covered pretty well the answer. Yeah, I would agree. And sadly, we don't have enough results yet about the effect of plastic on health. But I think more and more funding should try to go into that direction, because eventually the consumers, sadly, if it has an effect on their health, then I think this is when people will start moving and trying to find solutions. So I think that's one of the reasons why also we should push science on this side, and just because, yeah, it has an effect on human health. So maybe, I mean, my neighbors will stop consuming plastic because they'll be afraid of it. But yes, sadly, it's not everyone that is as affected as we are about like the effect on the environment and wildlife. So it takes a long time to change habits, as I mentioned before. And yeah, so I think research and funding for this type of research should be highly encouraged. So it's in high need.
Yeah, yeah. And I think that kind of leads into one of the other questions that I sort of did give a heads up that I would ask. So there have been some critiques that you know, maybe we don't know enough, or that the harms of single-use plastics are actually overstated. And then also there are climate and environmental activists who view these efforts around things like single-use plastics as a bit of a distraction from maybe more urgent environmental issues. I think we started to get into that a little bit in talking about, you know, shifting away from waste reduction to like the consumer end and the reuse culture. But any other comments on how you would respond to these types of critiques? Jonathan,
Maybe I can jump in quick.
Yeah, jump.
Oh, no.
Go for it.
While I'm not being too distracted. So yeah, I think, I mean, with the fact, the pollution that we see from plastic, 40% comes from single-use plastic. So I don't quite understand the critics, and I read a few articles on the topic, and I guess it's just, yeah, a way of defending single-use plastic. But I still think that, I mean, we visually see it, and a lot of this trash that is like used a few minutes and then discarded in the environment is out there. It degrades and fragments faster. So for example, in Hawaii, we won't see any plastic bags that cross the Pacific Ocean and the North Pacific garbage patch. Very rarely we see straws and forks, but it's because the type of polymer that is being used is very weak and it degrades and fragments faster, but still the waste is out there. And the numbers prove that about 40% of the trash discarded in some of the worlds will be from single-use plastic. So I don't quite agree with this, and I think it's an easy solution to fix, much easier than trying to, I mean, make computers out of only metal rather than, you know, these are durable plastic, and they have a better use than single-use plastic, I would say this way. So single-use plastic, I think that's an easy fix. It's just that we have to fight against the industry, and then we have to encourage our law and policymakers to make better decisions for the environment. So yeah, I'll keep it short. I have a lot more to say, but I'll keep it short.
Sure. Yeah. Thank you so much.
I'd like to add on a thought here. So, Rebecca, you sent the panelists a link to one of these articles, myth-busting 5 common misperceptions surrounding the environmental impacts of single-use plastics, and noted that the source of the article is University of Michigan. And it got me thinking about what I have long seen happening, which is that the plastics and the chemical industries, like many other industries, are infusing millions of dollars into large academic institutions. You know, as these institutions over decades have as government funding for research and academic research and academic programs has diminished over the last few decades, industry has been filling in the gaps. And University of Michigan is one of those universities that has been getting a huge amount of funding from the chemicals, which is also the plastics feedstock industry for a long period of time. So I think you need to be, like, here's a great research question for some of the technical folks in your organization. Just start following the numbers. You know, what are the schools of, who's funding the schools of sustainability, the packaging programs, the plastics research, where's that money coming from? So I just view this with a huge amount of skepticism. And this article, you know, we could talk, there's 6 bullet points in there. We could spend, you know, an hour deconstructing each one of them, but I think that the source is very suspect.
That's great. That reminds me of Jonathan's note in your presentation about questioning where the numbers come from. And yeah, did you have other?
I sort of wanted to defend Shelley. So Shelley Miller was the source of the article, who's a colleague. So I definitely think that we need to sort of, you know, understand the source of funding throughout. But it's also important to remember that, just like you said, when you're talking about LCAs, the output of these models depends a lot on the way you frame the question going in. And so, right. You know, I think that the framing of that study was about comparing the effects of packaging to other sorts of products, not dismissing the idea that packaging doesn't have an environmental, dismissing the idea that packaging has an environmental impact altogether. I think, you know, if you have a single bottle and you wanted to prioritize what to do in order to reduce the environmental impact of that single bottle with, you know, single manufactured bottle, the LCA that Miller and others do would show that the biggest impact would be to change what's inside the bottle. If you're looking at all the bottles, then it's a different question, so you get a different answer. So I think maybe I'd like to add a bit of nuance there from, being a fellow academic to this person who was also quoted by a journalist, and that is always a fraught conversation, which is, it's important to keep scientific conclusions in the context in which they're generated.
Yeah, and I was just going to say, I think my takeaway from that article is actually, I don't think that like the end answer, like we would necessarily, anyone on this call would disagree with, which is we do need to think more about kind of the upstream effects of what we're consuming versus just focusing on like some of the recycling efforts, which, Miriam, you've been mentioned, like the recycling and composting. Like really need to think critically about how those actually help or don't help the environment. So I do agree. I think like, these are all coming from, at least from my reading, a place of wanting to understand where kind of the key choke points are. And Miriam, yeah, I'd love to hear your response.
Well, just on the communication side, something that I've been thinking about a lot lately is that we also need scientists to learn how to communicate better for the general public. It's a constant challenge in my community and the advocacy community. The general public does not understand scientific and technical nuance. So we need for technical people to, when they are communicating in the public sphere, to learn how to communicate messages that the public can easily digest.
Yeah, definitely. As someone who's in the infectious disease research space, that's been a point near and dear to my heart recently. I want to get to a couple of kind of audience questions that have come up. So there was one attendee who was very impressed, Jonathan, with your efforts to get into policy while doing your academic research as a doctoral student. So asking how you would suggest other graduate students or early career researchers who, especially as they say, if their advisors are maybe not as focused on their post-PhD career goals, how you would suggest building that time in. So I'd love to hear from you, but also Miriam and Sarah as well, for ideas of how some of the students or early researchers on this call could engage.
Yeah, so I can't say that I had the most reproducible academic career. I did have advisors in both my master's degree and my PhD who were sort of willing to tolerate some of my extracurriculars, but I was able to justify my time because they were so aligned with sort of the work that I was doing. There was certainly an element of I took risks. I wasn't so concerned with how my, approaches to, I wanted to have an impact then. I wasn't thinking so much about how this was going to impact my long-term sort of competitiveness as an academic. I think I was feeling like the most important thing was that I wanted to do this, to tackle these sorts of projects. And if I couldn't do that as a tenure track faculty member, so be it. That's ended up being what has happened. I'm starting in July, like a professor of the practice position in BC's new engineering department, not a tenure track line, and that's fine. And so I think a bit of it is sort of to think about what matters to you in terms of your academic career. Why did you choose to be an academic in the first place? Take some risks. Be willing to piss off your advisor. And yes, I mean, AAAS Science and Policy Fellowships, amazing. There's other opportunities like that. Reach out to organizations like Miriam's, there's always sort of research opportunities. They can connect you with people and just start hustling.
Nice.
I had a very similar experience. Actually, it's interesting to hear from you, Jonathan. Being a biogeochemist, biological oceanographer, measuring gases in the ocean, for a long, long time. And then when we made the unexpected discovery that plastic is producing greenhouse gases, I bugged my advisor for, it was a postdoc. So for 3 months, I was like, I want to do this work. I think this is going to be important. Can you please let me do it? And he didn't want to, because he's like, I'm not getting funded for plastic research. And I bugged him so much and I troubled him so much, and he said, fine, do it. So he gave me 2 years to do it. And then, I mean, sadly, there was no funding. So I changed lab and I continued doing plastic research after publishing this one. And yeah, I remember Nikolai was a great mentor, but he was like, Sarah, you need to have your own work and then add plastic as a research interest, but not to be completely your science focus. So I didn't listen to him, and then I left this lab too, and then finally I found my way and found funding. So it took some time, but it's just because I thought this is so important, and plastic research 10 years ago was not so important. I mean, it was not as funded as today, and the amount of papers that were published was very low compared to today. But I guess I just follow my heart, and I started picking up trash a long time ago. So I mean, it was always something inside me that wanted to help, and I was like, okay, then I'm going to use my science to reach out outside of the scientific community to show that this is a big issue and we have to do something about it. So basically everything was about trash in my life. I would do beach cleanup over the weekend. I would do talks during evenings, and I will be with organization and schools. And then during daytime, I would do my research. So it's really it's how I discovered my passion and how I wanted to use my scientific skills to for a bigger problem and to try to help, but not only with the scientific research and community, but also ways of sharing the information outside and having an impact with law and policymakers. So follow your heart, follow your dreams, and you'll always find a way.
Nice. Miriam, did you have? I think you've already put some great resources in on the chat of specific organizations people can reach out to.
I think if you want to get involved in the plastic pollution movement, there's all kinds of parts of the life cycle of plastic that we're working on in the movement. The Break Free from Plastic movement is now about 8,000 groups across the globe. I think about 2,000 in the US. So I invite you to, join Break Free from Plastic if plastic is a passion for you, and figure out where in the life cycle, do you want to focus on the extraction side, communities impacted by extraction, by processing, by consumption, waste disposal. There's all kinds of groups working in all different areas of the plastic life cycle. So that's one. And I agree with a lot of the suggestions in the chat. I mean, there are zero waste commissions, there are zero waste organizations at the local level. I'm happy to try to connect you. So yeah, really great opportunities at the local level. Yes, and the Break Free from Plastic Pollution Act, I should have put our action link in, is something that we Upstream has had an impact in getting some reuse provisions incorporated into that act in its reintroduction. So we're really excited that it isn't just going to be about stopping the build out of the plastic processing, plastic infrastructure. It's going to stop the export of plastics waste overseas. It's going to create a national beverage container law, but it's also got some reuse and refill provisions in there. Really exciting.
I know we're heading up on 2:30 Eastern time. There was one question, so if any of the panelists have to jump off, please feel free. I did note that there was one question that came up, which we were discussing earlier, around the impact of the current pandemic on the single-use plastic reduction. So I know you have a lot of opinions on that. We were just discussing, if you wanted to share really quickly, any closing thoughts on that? I think that's maybe a good thought to wrap up on.
Miriam,
I didn't hear what you said. Sorry.
Oh, it was a question on the effect of COVID on both the quantity and quality of plastic waste, and also the effect on the policy action.
Yeah, so actually, COVID has obviously ramped up single-use plastics from PPEs and foodware, food and beverage packaging, especially as food delivery has increased about 78%. So the concomitant waste stream has increased dramatically. I didn't bring the numbers with me, but what we've done in our policy work is both to defend against things that have already been enacted, like reusable bag policies and reusable cup and bulk grocery delivery systems that have been under attack from local and state health guidance around COVID. We've gotten a lot of those attacks. We've been able to reverse them. But at the same time, COVID has served to really increase public concern about single-use plastics because people can see how much more is littering their streets and in their communities. So what this has done has really driven a huge amount of increased interest at the local and the state level for solving the plastic pollution problem. And so our reuse policies, while they were put on hold during COVID, they're actually getting a lot more traction as a result of this huge rise in single-use plastics right now.
So I think we're wrapping up. If there's we're a couple minutes past, so thanks for taking that last couple of minutes. I just want to thank all of the attendees there's a really robust discussion in the chat, and we'll save and capture that. And to all of the panelists on these webinars, you can't actually hear the rest of the people, but I want to give a round of applause because this was fantastic. I learned so much. So thank you for being with us this afternoon or early morning in Hawaii, I guess. Yeah.